Hi, everyone. Welcome to Talk Tech with Data Dave. I am Alexis, your host of this podcast, and I'm here today, as always, with my dear friend, Data Dave. Hey, Dave, how are you?
I'm very well, Alexis. How are you?
I am
Glad to be here.
good. Yeah. This is it's midsummer for us right now. We are in conference season. We've got all kinds of fun things to talk about. But before we talk about our question today, I do want to remind our listeners that you can always submit a question to us at talktech@d3clarity.com or right on the D3 Clarity website. We love to answer your questions about all things data, all things cloud, all things technology, all things AI, all things D3 Clarity right here on the podcast. Talk Tech with Data Dave is brought to you by D3 Clarity, offering clarity for improved decision making. D3 Clarity delivers profitability multipliers through better data and digital infrastructure. For more information, contact D3 Clarity at d3clarity.com. So, Dave, let me ask you this question. How does AI learn and make decisions? We have talked about AI and machine learning quite a bit in our last few podcasts, but I want to go back to kind of the core here. How does AI make decisions? How does it learn? Because I know it does, but I don't really get the concept of how it gets to the point.
Okay, so interesting question, Alexis. That's a very interesting question. I'm not sure a lot of people completely understand it.
I know I
Um,
don't, so I'm excited
let's
to hear your answer.
let's go back to um, a little bit of basics. We're not going to go into deeply into very modern AI, but let's go back to the very basics of a couple of fundamental technologies that are used in AI, and I'm going to talk about. You can certainly talk about more, and we'll go through this. So one is a decision tree, right, and one is a neural network.
Hmm.
Okay, so you've heard both of those terms before,
Yes, we've definitely talked about both of those before on the
right?
pod even here.
So a decision tree is a series of decisions in a tree which allows you to lead to an ultimate decision. So based off of these two inputs, I'm going to decide is this green or blue? Is it green? If it's green, maybe it's a leaf kind of decision tree down that path.
Okay.
And we are in coding, we often make decision trees naturally, right? Because a set of inputs leads to a set of outputs. We define the decisions and we work through that as a logical progression.
So to simplify um, down to kind of Alexis basic Excel level, because my brain's on Excel right now, like an if-then function, right?
Exactly. And
If
it's
the
a set of
number is between 90 and 100, then it's an A. If it's between 80 and 90, it's a B, so on and so forth.
right, exactly. So it's this decision tree that says if you scored this, then it's that, right? And working through that as a if you build those up into a tree structure where you say, if I make that decision, then this is the next right decision to make, et cetera, et cetera. So you build up this tree of decisions.
Hmm.
So that's a decision tree, and it's a logical representation, right? You can build one, you can naturally work with them. With machine learning, what we do is we compute the decision tree. So we feed it all the inputs, and then we feed it all the outputs, and we let it decide what set of decisions it could make to lead to this decision, right? And if you think about a simple decision, right, where you say less than 80 equals a B, greater than 90 equals whatever you're grading in paper, right?
Hmm.
And you could have a simple decision. It'd be fairly easy for it to determine, given 300, a class of 300 students, it could fairly easily what decide what the grade point is for an A and a B, right? Because you told it, I gave this person an A and she scored 91. I gave this person a C, he scored 70. It wouldn't be long before you could say, okay, and a C is lower than a 70, a B is between 70 and 90, and an A is above 90.
And that would be the decision tree figuring that out
That would
itself.
be that would be the machine learning
The machine learning.
deciding
Okay,
what the decision tree is based off of the inputs and the outputs,
got it.
right? And that's a very simple one, right? And then you can extend that to 10 inputs, 1,000 inputs, right? And a complex decision,
Mm-hmm.
because it will, if you've got enough data, it will run through that data to produce this set of decisions. Does that make sense?
Yes. Okay.
Right. The one I wrote the other week had about 50 decisions in it off of 16, 17 points of data. No, and more than that. I had hundreds of decisions based off of about 17 points of data,
Uh-huh.
a matrix of data, right? But I didn't want to compute it all myself, so I just taught a decision tree how to do it. Does that make sense?
Huh.
Right. So that's a decision tree. Very deterministic, very interesting, pretty rigid.
Yeah, it sounds like it.
Right. It's pretty rigid. And then when you want it to do something else, you have to reteach it. So then we get onto neural networks, which are a little more fluid, shall we say, a little more mathematical, a little less deterministic.
Mm-hmm.
And what this is computing is the relationship between the inputs and the outputs, between the question and the answer. Does that make sense?
Yeah, it's figuring it out.
Exactly. So it's figuring out a mathematical relationship between the inputs and the outputs.
Mm-hmm.
Okay. The first neural network that I wrote was one that I taught how to do basic arithmetic.
Okay.
Right. So I said, let's take two numbers and add them together, but I'm not going to do math. I'm going to teach a neural network how to do math. Does that make sense?
Yeah.
So I did. So I built a data set that was a set of random numbers between 1 and 10, and then computed the answer for each of those numbers, and it was about 1,000. I don't know, some number of results. Then
Mm-hmm.
I wrote a neural network that took the two numbers as input and produced the output. Right. So what it was doing, what it does, if you think back to your high school mathematics, and you think of your basic linear algebra, right? Y equals mx plus b for a linear relationship between two variables.
Yes, I love y equals mx plus b, a good linear regression. That's
Right.
I was good at high
Exactly.
school math, Dave. Like that's something I understand. Okay, keep going.
Right. So you just said a key word there. You said the word regression.
Yes.
Right. So that's exactly what this is doing. You're basically creating a regressor from the points that you give it, which is the data that you're training it on. It is generating the equation of that line that now lets it regress that mathematical relationship across any points that come in. Does that make
So
sense?
you're having it figure out what m and b are in the y equals mx plus b equation.
Exactly.
Yes, okay.
Exactly. You're having it figure out and work out what the m and the b are. So now you can feed in any value of x and it will produce a value of y. Right? With
Uh-huh.
any number of variables on that x-axis.
So if you teach it 1 plus 3 equals 4, it and it figures out the equation, it can you don't have to teach it that 5 plus 4 equals 9. It can figure that out
No,
itself.
it can figure that out itself. If you give it enough that it's figured out the m and the b, it will work that out. It will
Mhm.
give you. So now you've taught it how to do that basic arithmetic.
So you could teach it because you're teaching it that and you're teaching it an equation, you're not teaching it math. You teach it wrong math, right? Or you could teach it like a different base. So
Yes,
instead of doing a
absolutely,
base 10 math, you could teach it base 9 math
absolutely.
and just feed it in.
Yes,
Oh, that would be
absolutely.
super fun to just mess with my dad. Be
Yeah.
like, here, Dad, here's a calculator, and then all of a sudden it's feeding out that 5 plus 4 equals 10.
Mm-hmm. Right.
I mean, that'd be a good time.
Well, it's
Okay,
still
sorry,
nine,
I
but it's
digress.
represented as 1-0, right? But
Right, because
yeah.
it's base 9, right? Yeah.
But yes, you could teach it base 9 math. You could teach it anything. You could teach it just complete garbage. If your data is complete garbage, if your
Garbage
input
in, garbage
data,
out. We've talked about that before. Yeah,
exactly, if the data that you're feeding it isn't accurate and therefore your regression line is incorrect, then your answer is always going to be wrong.
for sure.
So
Okay, so
that's the fundamental of how a neural network, a decision tree makes a decision. right? Makes a straightforward decision. And
So
we
we
use
have
that quite a
talked
lot.
about AI versus ML before, artificial intelligence versus machine learning. That to me sounds more like machine learning than artificial intelligence because you're doing input output. You're not doing you're not having it kind of learn in a different way. I don't know. Is that right? Is that
So
machine learning?
so
Or is there a difference here?
from my definition, from my definitions, yes, that I would agree with that 100%. This is about machine learning, and it's teaching a machine to repeat decisions that you would have made based off of a rule set that you have defined. You've entered into the inputs, you've entered in the outputs, and you've taught it the, and it's inferred the rules that lead from this input to that output.
Okay. Okay.
So that to me is more machine learning, right? Now, artificial intelligence, um,
I was hoping we
interesting,
were going to get there, so I'm happy.
interesting,
Yes.
interesting term. So there's a number of ways things learn, right? So you can learn like we just talked about, which is a supervised learning. Here's a data set. We're going to supervise the learning unit, come up with this. There's also the and we're just about to put out a white paper that goes into some of this different learning. So that then there's unsupervised learning, which means as you interact with it and as you say whether the answer that it gave you was right or wrong, it grows, it learns as it goes,
Mm-hmm.
right? And that's less supervised or unsupervised. So those are two of the basic forms of learning. How does AI work? Well, you have to ask, what is AI doing? A lot of it is just, again, more and very complex mathematics,
Mm-hmm.
right? And the size of the equations that you're solving for. For example, when you look at machine learning and AI for recognizing images, recognizing people in images or something like that,
Mm-hmm.
the image is just a matrix of numbers, right?
Right.
It's
Which I
it's
I inherently know but don't understand. But yes, okay.
well, okay, let's talk about it. So if we drill into that for a minute, you've got three planes of red, green, and blue, usually in an image for color,
Mm-hmm.
right? Each color is broken down into I'm just going to use a number, 4 million, so 4 byte structure. So you got 4 billion representations of the color green, blue, and what's the third one? Red,
Red.
right? So you've
Red, blue,
got,
and yellow, right?
well, it's actually red, blue, and green when you talk about light,
Or
but that's a
BG.
different
Yeah. Okay.
conversation. Yeah. Um, so so you've got those three colors, each pixel. So when you talk about a 3 megapixel camera, right, there are 3 million pixels in that image,
Okay.
right? So 3 million of these items that are each RGB color, RGB color. So every pixel has that amount of data behind it.
So it has one designated color per pixel, which is why if you end up like zooming in, you get a
You
you get a
get
super blurry image because you end up with different
we
colors in different places.
we're ending up
Sorry,
with
my brain is walking through this really fast, and I'm like, wait a second, I think I understand this now.
right. You're looking at the pixels, right? So you're looking
Hmm.
at a pixel is a color. That color is a blend of RGB. Each pixel has a number behind it for RG and B, and it represents like this. So when you zoom really in far, you get it to pixelate, right? You get to
Hmm.
see the individual dots versus the whole image,
Okay. Okay. So
right?
so yes, there's a whole bunch of numbers behind the picture of my face on the screen right now
Exactly. There's a whole
that
bunch of
represent
numbers
color,
behind it.
basically.
Right, exactly.
Okay.
Lots of them,
Hmm.
right? So when you look at these AI to recognize that, you start to compute differences between pixel patterns on the RGB level. So you're mathematically saying there is a boundary between your face and your hair, and that boundary starts to kind of look like a face shape,
Okay.
or to the background and to other things,
Uh-huh.
right? Does that make sense?
Yes, I'm following you.
Right. And then it starts to say, okay, well, if that boundary is kind of that shape, then it is likely that that's going to be a face, because I've been taught that faces look like this and have similar boundaries in them.
Mm-hmm.
So there's a probability that this set of patterns that I've detected are a face. Does
Okay,
that
I'm
make sense?
following you. Yes.
So there's no magic in this. It is very similar to the way that we recognize things. To a certain extent, it's based off of a lot of science and whatever of how the brain works and how we make decisions. But there is no magic here. It is finding the patterns or the features in the image by some mathematics, right? Which I'm not going to go into, by some mathematics. And then it's saying, because of those patterns, and because those patterns are in this pattern, and when I looked at a whole bunch of faces, they had similar patterns and similar areas, similar features and similar patterns. So therefore, it's likely that this pattern matches this pattern, right?
So
Makes sense?
for the picture example, going back to the basic question, how does AI learn and make decisions? You're feeding it a set of examples.
Yep.
You're saying this is what I think a face looks like in a
Yep.
picture, and then you're saying to it, giving it another picture and saying, "Do you think this is a face?" And then saying yes or no,
That's right.
and then
Essentially,
us telling it if it's correct or incorrect.
essentially, yes. Essentially, yes. Or you're feeding it a truck and saying, "What's this?" Right? Because you've taught it trucks and faces.
Hmm.
So now it can say, "Here's a car. Here's a face." Whatever you've taught it, and that's usually called a classifier. So now you're classifying those images.
Okay. So it's
Right.
learning from examples and correct versus incorrect. I feel like
Yes,
we've talked a little bit of that before.
it's learning from examples and learning from the answers that it's been given.
Hmm.
Right now, it can also learn when you give it feedback. Right, you can say, "Well, actually, that's not really a face. That's a dog, not a person." And if you've programmed that, then it will reclassify that image as a dog, not a person, and then it learns from that and continues to move forward. So often these are continually learning.
When I ask Dolly to make me a picture and um, I don't like something about the picture, like I tell it I want a picture of an iceberg, and instead it gives me a picture of an iceberg with the Titanic. And I say, no,
Mm-hmm.
I don't want the Titanic. I just want the iceberg. Is it is it learning in and of itself that when you say iceberg, it doesn't mean you also want Titanic? It means you just want an iceberg. And next time I ask for an iceberg, will it be like, oh, I don't want to give it Titanic. I just asked Ollie to make me an iceberg picture. That's why it's on my brain.
Not necessarily.
So no, it doesn't get that feedback from me.
It it can, and some do, but it doesn't necessarily. What it is doing is it's saying, "Oh, of all the libraries that I have of images that are tagged with the term iceberg, right? I am going to give it the best one that I can produce. It just happens to have a ship in it.
Hmm.
So if you then add context to say, I want an iceberg without a ship, then you've essentially narrowed its classification into the image library that it can draw from as its base image set,
Okay.
right? So you're classifying it down to saying just this. Now that's if it's just looking up and reading within an image set within a library. If it's generating it, then a very similar thing happens, but it uses that image set to produce essentially a random image that it then feeds to a classifier and then says, does this look like what she asked for?
Okay, talk to me a little bit more about that.
So the generative AI piece, rather than looking up in a library of images, says, okay, I'm going to generate an image. Well, essentially, go back to the numbers that make up an image,
Mm-hmm.
Well, essentially, you could make an image just out of a whole bunch of random numbers, right?
Yeah.
It might look a little odd, but it would be a whole bunch of random numbers. Then you could test it and say, does that look like Alexis? And there's a good chance that it doesn't, right?
That's true. Yeah.
But now do this a billion times, and you're into the Shakespeare and monkey analogy, right? An infinite number of monkeys with an infinite number of typewriters will eventually write the complete works of Shakespeare.
I've never heard that before, but
You've
that
never
makes
heard
sense.
that?
Yeah.
Right? No disrespect, but it's right. It's an old adage.
Infinite number. Yeah.
Right? So you can generate a whole bunch of random numbers, feed it into another classifier, and say, okay, is it one of these? The answer is highly likely to be no. And then it guesses again and does it again. Well, if you apply learning to that so that you go back to your M and B idea and say that every pixel, you've actually asked it for a picture of Alexis or a picture of certain things. And every pixel is generated using some mathematics, right? So now you start to say, okay, every time I say, no, it's not what I want, it adjusts its mathematics to get closer.
And if
So
you did that an infinite amount of times, you would eventually end up with.
If you do that enough times and then seed the random number generators with a library of images, you will generate the right random numbers that are probably a good approximation towards Alexis.
Yes.
And then you test it and put that through a classifier that says yes or no. When they are in a good adversarial discussion, right, these two engines, then you've got an image generator. Then you've got what is generative AI. And you've heard the term a GAN, right? A generative adversarial neural network.
Yes.
So you've got two neural networks working adversarially to produce an image that looks like it might be one of these.
It's just doing it really fast.
And it's doing it very fast, and it's learning from it as to how it's generating its essentially random numbers. They're not random anymore, right? How it's generating its numbers that produce an image. It's then doing that. So it's all the mathematics behind it to do all this sets of regressions. It's just doing a tremendous number of them. And they don't have to be linear functions. We use linear because it's easy to understand. But when you start talking about the nonlinear functions and fitting curves and different things to structures, and then you're talking about hundreds of thousands to millions of these points in an image, you start to get quite interesting, right?
Yeah. Okay.
Right.
So
and that's why you need so much compute power to do this. It's a lot of work.
I'm going to ask you the question one more time. And I want you to give me like 30-second answer. Let's do a recap. How does AI learn and make decisions?
So AI learns by tuning mathematical algorithms that give a inference between the inputs and the outputs. How
Very
was that?
good. That was perfect. I
Right?
want to talk more about generative AI in another episode for sure, but I think that helped me understand the back end of AI a little bit more, especially as we head into like the age of AI, if you will. So very, very, very interested to talk more with you about that. This was a good
Okay.
stuff. I like this. Okay. Well, thank you, Dave, for joining me today. Listeners, I super appreciate you being here. Make sure you send us your questions at talktech@d3clarity.com or right on the D3 Clarity Network. Dave, like I said, it's been a good day. I feel like I've learned so much already.
Okay, thank you. And thank you, listeners.
If you have a question for Data Dave, reach out to us via email at talktech@d3clarity.com. We'll be happy to answer your questions in the podcast. Thanks. This podcast has been brought to you by D3 Clarity. No one has time or patience to fix all of their data and infrastructure problems. D3 Clarity helps some of the world's most recognizable brands take the right action to turn their information into strategic profit making. For more information, go to D3 Clarity. That's the letter D, the number 3, the word clarity.com.